Okay, good morning. Good afternoon, actually. So this one is just the continuations of Unit 3 for Semester 1, Geometry Semester 1, Unit 3, the pretest analysis. Let's see this one right here. So it's a word problem for number 23. So a cell phone tower casts an 80-foot shadow. At the same time, a 6-foot fence post casts a shadow of 4 feet. And what's the height of the tower? So first thing that you want to do, you want to draw the diagram, or also you can compare the number. But I do recommend you to draw the diagram for this. So again, it's about the comparison of two similar right triangles. Okay, so let me just copy and paste. Okay, so once again, so two similar right triangles. So again, anytime that you see the word problem like this, so the way that you read through it, you always want to annotate it. So you want to highlight a key number. So the tower, we don't know how tall that is, but the thing is that it casts a shadow, 80 foot, okay. And then the other one, what we got, it's a fence. It's about, well, it's a 6-foot fence and casts a shadow or 4 feet. So one thing that you can do, just draw the diagram. So the tower, and here's the shadow. So this one is 80 feet. Again, it's a right triangle. And then the other one is a fence. So that is, that's 6 feet tall for the fence. And that casts a shadow of 4 feet. Well, the reason why that's a little bit shorter, because that, depending on the way, the sun is going through to the tower and also to the fence. So this one's 4 feet. So again, it's all about the comparison of the similar right triangles. So this one, we need to find out the height of the tower. So again, shortest leg versus the shortest leg. So it's 4 over 80. So that equals 6 over h for the comparison. So this one, you want to cross multiply. So we do have 4h. And then 80 times 6, which is 480. And then you divide it. So you end up with 120. It's 120 feet with the unit. Okay, going back to the selection here, so 120 feet. So for the next two word problem, they're quite similar. It's the same kind of structure. Just got to be careful with the number that you line up here. So it's always about the distance of the shadow versus the distance of the shadow, and then the height of the tower versus the height of the fence. But this one is a straight sign, okay? So got to be careful with those two numbers, the way that you put them on sides, the way that you set up for the proportionality statement. And now here's another word problem. So during a game of pool, Kyle hit a ball and it followed the path from point B to point C, and then to D. So B to C and then C to D. And the angle formed by the path are congruent, okay, congruent angle. And then to the nearest 10 of an inch. Which of the following represents the total distance the ball traveled before it stopped at point D? So you want to find the distance from point B to point C. Well, that's given already. And then, but also you need to get the distance from point C to point D. So once we get the distance from point C to point D, we can combine this together. So again, as you can see that this one, we do have two similar right triangles. Okay, so let me just copy the diagram. And then I want to transfer that to the active inspire. Okay, so copy and paste. And the number we got here, so let's see, we got 9, 21.5, 48. So here's what we got here. We got 9, 21.5. I believe this one is 48. Okay, so again, it's about the comparison of two right triangles. So what we need to do first, we need to find out the distance from point B Let's see, I cannot read that letter. From point C to point D. Okay, so this one's from point C to point D. So first thing that you want to do, you want to set up the proportionality equation. So again, the height versus the height, and then the hypotenuse versus the hypotenuse. So let's say this one, it's x. So what we can do with the proportionality, it's 9 over 21.5. So that equals x over 48. Again, what I did here, I just compared the height, and then I compared the hypotenuse, because they both have the exact same similarity ratio. So 9 over 21.5, we don't know what that is. We can always cross multiply this first. So let me use my calculator here. So 9 times 48. So we got 432. So that equals 21.5x. And then divided by 21.5. So 432 divided by 21.5. So here's what we got for segment CD. So for x, we do have about 20. It just rounded up, so we do have x 20. But according to the instruction, let's see. So you want to round it to the nearest 10. To the nearest 10, so that means it's considered 1 decimal place. So this one will be considered 20.1. Again, you have to round it to the nearest 10. Now, so we found a distance from point C to point D, but we need to get the distance from point A all the way to point D. So basically, we need to combine that 21.1 and 48 together. So we'll end up with 68.1 and feet. Oh, inches, excuse me, inches. Got to be careful the unit, so the unit got to be matching with what it's being given here. Inches. All right. So those are the word problem. You guys need to slow things down a little bit. So again, if the diagram is not given, so draw the diagram first. But before you do anything like this, make sure that you need to read through the problem, and also try to annotate, the number that's given, all the key word, the key factor. Very important. And 24B is quite similar. So 24C is pretty much the same kind of model. So we're not going to spend the time to work on those. You guys can just still look at that 24A, the one I did. So now the next one I would like to talk about is the special right triangles. So we do have two different types of special right triangles. So one is 45, 45, 90. Okay, let me just do it on this right here. So 45, 45, 90. So we can say that it's an isosceles right triangle. And the other one, it's considered 30, 60, 90. Let me just reschedule this one here. So this one should be a little bit skinny. Shorter. Okay, so 30, 60, and 90 degree. As you can see that I used the same art for this, but this one, different art. Single, double, because those two angles, they're not the same. 90 degree, perpendicular. So now, another thing that you need to know, it's about the ratios of the line segments. So the ratio of the line segment here, what we got, it's 1, 1, and then root 2. And then what about for 30, 60, 90? And also this one can set up the ratios. So it's 1, 1, root 2. Now, got to be careful with the ratio. The ratio, that's not the exact same line, the distance of the line segment. They're just the comparison ratios, okay? So now 30, 60, 90. So the ratio we have is 1, root 3, and 2, okay? So set up the proportionality statements and also the comparison. So start with the angle first, and then the ratio, so 1, root 3, and 2. Okay, so gotta be careful with the ratios. So those are the ratio you guys need to recognize. Okay, because now we need to apply it all the time. So once we deal with the special right triangle here. So the first one, what we got is 45, 45, 90. So the given segment is 4 root 2. Okay, so the longest leg is 4 root 2. And which of the following represents the ratios of the hypotenuse to the given sides? So back to what I show you here. So the comparisons of the hypotenuse and the given side, then that would be considered root 2 to 1. Same thing as this one here, root 2 to 1. So it doesn't matter which one that you pick. It's the same ratio, so root 2 to 1. Okay, so what we found here, so it's choice C. And here's another one. So again, find the given ratios. Find the ratio which is representing the side to the hypotenuse. So the ratio of the side, so you started with the ratio of the side first. So the ratio of the side, again, back to what I showed you. So you started with 1, and then the hypotenuse, root 2. So it's 1 to root 2. So the colon here, so that means 1 to root 2. Colon, so that means 2. It's a comparison of two ratios. And this one here, 45, 45, 90. So what's the ratios of the hypotenuse to the given side? So again, starting with the hypotenuse first, root 2 to 1. And then what about 30, 60, 90 degree? Another right triangle. So the ratios of the hypotenuse to the shorter leg. So this one is 2 to 1, shorter leg. What they mean by the shorter leg? It's actually the shortest leg. So 2 to 1. Okay, so 2 to 1. Okay, so here's another one. So this one will be the ratios of the longer leg to the shorter leg. So longer leg to the shorter leg, then that'll be root 3 to 1. Shorter leg to the hypotenuse, so 1 to 2. Okay, so now 27, what's the length of leg S in the right triangle shown? Using the proportionality or the ratios. So this one is 5 root 2. If you divide it by root 2, so the shortest leg would be 5. So simply just get rid of the ratios, so you get 5. And 27b, similar. So the longest leg it's given. What's the shortest leg of the 45, 45, 90 degree special right triangle? So divided by root 2, so we get 7. And then this one would be considered the shortest leg. So in order to get the longest leg, you multiply by root 2. So 6 root 2. So 28, again, using the different ratios. So the shortest leg is 6. In order to get the longest leg, so 6 times the ratio of the longest leg, times 2. So we get 12. And this one, what we got here, it's the longer leg, 5 root 3. So it's the length of the shorter leg. Again, the shorter leg, what they mean by that, it's the shortest leg, the one that I've been talking about. So 5 root 3 divided by root 3. So we get 5. And then the length of the longer leg in the right triangle shown. So this one you need to find the shortest leg first. So 12 divided by 2, then you get 6. And then the ratios of the longer leg is root 3. Again, the diagram that I show you. So find out the shortest leg first. So 12 divided by 2, you'll get 6. And then 6 times root 3, you'll get 6 root 3. So the answer is D. Okay, so that's it. And this one is part 2 of the pretest analysis of Unit 3 for those students taking Semester 1 Geometry. Okay, so please just watch the video and let me know any questions I have. Okay, so I'll see you next time. Take care.